This question asks, what reagents are needed to bring about the following transformation? So at the start, this is a synthesis question. We have a starting material, we have products, but we don't know what reagents we need or how many steps we need. So our job is to kind of figure out how do we get from point A to point B. Kind of two main things to always think about when you have a synthesis question. Two questions to ask yourself. Number one, how has the carbon skeleton changed? Have we added carbons, lost carbons? Has it stayed the same? And number two, what kind of transformations have we brought about? So to answer question one, we have changed the carbon skeleton. We've gone from 4 carbons to 2 carbons. So that's a really important thing because there's only so many reactions that cleave carbon to carbon bonds. Next, what type of transformation has occurred via the functional group? We've gone from an alkene to 2 aldehydes. So right off the bat, that should hopefully throw a red flag out at you to kind of think about what one of the key reactions would be, and that's ozonolysis. Ozonolysis cleaves carbon to carbon bonds, and it brings about oxidations, which we are seeing here as well, because we've added carbon to oxygen bonds to the substrate. So we can kind of think about what needs to happen, and now we can think about the order. So in this case, we have a multiple choice question, so we can kind of work through each one to see which one is the best way to go about making the products. But if you don't have a multiple choice question, if it were open-ended, for example, you just have to kind of work your way through either forwards or backwards using retrosynthesis to kind of think about what reactions need to happen. So let's go ahead and think about each of our answer choices and whether or not they're viable or not. For the first reaction, reaction A, you might be thinking, maybe we could just straight up do ozonolysis of the starting material. And if we were to do that, we would kind of cleave this bond in half and add 2 oxygen atoms. And that would make 2 aldehydes, but they're not the aldehydes of the product. So we can cross off A as an option because although it does make aldehydes, it doesn't make the aldehydes that we're trying to make. So let's take a look at reaction 2. Reaction number 2 starts off with a bromination reaction. And it's radical bromination because of the presence of the peroxides right here. So this would create an anti-Markovnikov regiochemistry reaction where we add a bromine right here. Okay, next we have a strong nucleophile / base. So that would bring about an elimination. And from there, if we did ozonolysis, we would make the following products. Oops, I added a carbon there. Let me fix that. We would make this molecule and we would make this molecule. So the same 2 aldehydes from answer choice A. So we can cross B off as well. I'm going to kind of erase this so I can think about the next couple of reactions. If we take a look at reaction C, here we have hydrohalogenation, but it's going to give us Markovnikov addition now. So we would go from this alkene to this alkyl halide, and then take note of our base. This is a big, bulky, strong base. This is the same thing as tert-butoxide. If we use tert-butoxide, that will give us the Hoffman product. And if we did ozonolysis on that, again, we would get to the same 2 aldehydes from answer choice A, which again is not what we're going for. So answer choice C is also one that we can cross off. Let's take a look at D. Let me erase that so I have some space. If we take a look at D, again, we have Markovnikov addition. So that'll give us this alkyl halide. Now we have a small strong base, and that's significant because we get different regiochemistry. We're going to make a di-substituted alkane now. And this is the key to making our final product. When we do ozonolysis, we're going to make 2 of the exact same aldehyde, which is this guy. And that is actually what we're trying to make. So D is definitely a good option. But in synthesis, you always want to take into account, is this the most efficient route? So let's take a look at E too, just to be sure that that 3-step, actually 4-step, I'm sorry, reaction or synthesis is the best way to go. So let's take a look at our last option, E. In E, we are brominating to make this molecule. It would make this plus its enantiomer. And then we'd be doing osmium tetroxide. And this doesn't really make sense. Osmium tetroxide is going to give us a syn dihydroxylated product, but only from an alkene, not from a dihalide. So E is kind of a nonsense answer. It doesn't give us kind of products that we would expect. So we can cross E off. So now we can go back to answer choice D and confirm that it is the correct choice because there's not one that's more efficient than it. So only answer choice D will get us from point A to point B with major product formation.